Introduction to Statistics, Chapter 6, Discrete Probability Distributions, Section 6.3, the Poisson Probability Distribution. The Poisson probability distribution is similar to the binomial probability distribution in the fact that it is a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive outcomes. The two outcomes are usually referred to as success and failure. The difference is that the main idea behind a Poisson probability distribution is to determine the probability of X successes over a given interval, not a set number of trials. This is an interval, when success and failure are the only two possible outcomes. Criteria for a Poisson probability experiment. 1. The probability of two or more successes in any sufficiently small subinterval is 0. The probability for success is the same for any two intervals of equal length. The number of successes in any interval is independent of the number of successes in any other interval, provided the intervals are not overlapping. Notation to be familiar with. The Greek letter lambda represents the average number of occurrences of the event in some interval of length 1. The random variable x is used to represent the number of successes in an interval of fixed length. The letter t is used to represent the fixed length of the interval. Finding the mean and standard deviation of Poisson distribution. These statistics may be found by hand using the following formulas. The mean, mu of x, is equal to lambda times t. The standard deviation, sigma of x sub x, is equal to the square root of lambda times t, or the square root of the mean. A Poisson probability may be found using three different approaches. First, you could use the formula. If you look at this formula, it's not very nice. Okay, a lot's involved with it, and it would be complicated, easy to make mistakes entering into calculators. We will not be using the formula, but I wanted to make you aware that one does exist. Now, also, you could use a Poisson distribution table. Okay, since the Poisson probability distribution function was so time-consuming, a table was created. Now, your textbook does not include a Poisson distribution table, so we will not be discussing it. Using technology. Okay, again, many software packages include the Poisson probability distribution function built into Excel, Minitab, StatCrunch, which is a modification of Excel, are some of the commonly used software packages. We will be using StatCrunch to find our probabilities to save time and energy. Now, using StatCrunch is the easy part. Reading the problem carefully and knowing what you are looking for is the main part of the problem. Working problems using StatCrunch. Okay, very similar to what we did for a binomial. Read the problem carefully and determine the values for lambda and t. Read the problem carefully and determine what you are looking for. Are you looking for the probability x is less than some number, less than or equal to some number, greater than some number, greater than or equal to some number, equal some number, or trapped between two numbers? Now, understand the meaning of at least, at most, more than, less than, no more than, between, inclusive, exactly. This is the same thing we talked about with the binomial. Okay, and this probabilities are the same as what we discussed in binomial, so I'm just quickly listing them here, so recall for your memory. Now, use StatCrunch to get your answer. First, you're going to open StatCrunch. You're going to click the question help box and click StatCrunch. Click Stat on the top menu, highlight Calculator, select Poisson. If not between, choose Standard at the top under Poisson Calculator, enter the value for mean, which is lambda times t, choose correct inequality sign, enter x value. If between, choose Between at the top under Poisson Calculator, enter a value for the mean, which again is lambda times t, enter values for the lower x and the upper x. And then you click Compute. Now, using StatCrunch is not as hard as it sounds once you go through it a few times. We will now look at a few examples. From the practice exercises, I'm going to look at problem number 5. Okay, here, the random variable x follows a Poisson process with the given value of lambda and t, assuming lambda is 0.11 and t is 13. Compute the following. We want to compute the probability of 4, probability x is less than 4. Now, let's go back to A, probability with 4 in parentheses. This is actually the probability x equals 4. They just don't put x equals, they just put the 4 in parentheses. And then B is probability x is less than 4. C is the probability x is greater than or equal to 4. D is the probability x is greater than or equal to 3, less than or equal to 7. And E, you're going to find the mean and the standard deviation. Okay, so if we go up here under question help, click on question help, you see a lot of things listed here. Now in the practice, you know, view, help me solve, view, video, all this will be listed. When you do the quizzes, I think the only thing listed is StatCrunch and maybe Ask My Instructor. Okay, no, I don't think, I think it's just StatCrunch is showing up. So we click StatCrunch. Now we're going to go under Stat, highlight calculators, go down the list until you see Poisson, click on Poisson. Okay, now what do I need to enter here? Well, to enter here, I need to have the mean. Okay, now the mean is going to be lambda times t. So in this problem, lambda was 0.11, t was 13. So if you take your calculator, take 13 times 0.11, you will end up with 1.43. And now the first part I wanted equals 4. So I put equals, put 4 in. Now if I compute, there's my answer. Now if I go back over here, and it said round to 4 decimal places. Okay, so I'm going to click in here. 4 decimal places would have been 0.0417. Okay, and now we can check our answer, and it's excellent. Now we go on to the second part. Now the second part wanted less than 4. So I have this already up here. I already have my mean. I already have 4. So I just change my inequality to less than. And click compute. Now I have less than. Make sure it's still 4 decimal places. Yeah, still 4 decimal places. So I entered in here 0.9428. And I can click check my answer, and that's good. Now the next question was greater than or equal to 4. So all I got to do is change my inequality to greater than or equal. Click compute. Well, it actually automatically computed it. So now I go over here. So this is 0.0571, actually 2. 0.0572, yes, 4 decimal places. Okay, so I check my answer, and that's good. Now I want trapped between. So now up here under Poisson calculator, I'm going to pick between. My mean stayed there at 1.43, but I want between 3 and 7. So I change to a 3, my lower end, my upper end to a 7. Click compute. So now I have this answer. Okay, so it's 1737. Gonna have to close this. And check my answer. Okay, Now the last thing it wants the mean. Well, the mean we found early on as 1.43. Okay, now, so we check our answer. Okay, now we want the standard deviation. Well, the standard deviation is going to be the square root of the mean. So you take your calculator, take the square root of 1.43. My calculator wasn't working. Okay, it rounds off to 3 decimal places. So this is going to be 1.196. And check your answer. Okay, so that's using the Poisson distribution. Now the next problem is going to be very similar but with an added feature. So I want to do number 6. Now this time, the number of hits to a website follows a Poisson process. Hits occur at a rate of 1.8 per minute between 7 p.m. and 12 p.m. Given below are 3 scenarios for the number of hits to the website. Compute the probability of each scenario between 9:40 p.m. and 9:46 p.m. Interpret each result. Okay, before we can use Poisson, we need to find the mean. Well, if we look at this carefully in the problem, lambda is 1.8 per minute. So lambda is 1.8. Okay, the interval is from 9:40 p.m. to 9:46 p.m. That is 6 minutes. So t is 6 minutes. Now remember, lambda and interval must be in the same unit of measure. It's 1.8 per minute, 6 minutes. So they are. So you take 6 times 1.8 to get your mean. Now, and that turns out to be 10.8. So if we go to StatCrunch, click Stat, highlight Calculators, go down to Poisson. Now the mean, I said, was 10.8. And the first question is, we want it equal exactly 4. Exactly 4, now they go ahead and give you the formula. P equals 4. So we want equals 4, compute. So this is round to 4 decimal places. Okay, so this is going to be 0.0116. And I check my answer. Fantastic. Now, the next part, it asks you a question. On about blank of every 100 time intervals between 9:40 and 9:46, the website will receive blank blank hits. Okay, what we're going to do here, this first square, okay, you notice it says round to the nearest whole number is needed. That's going to be important. You're going to take 100 times the probability. Okay, so if I take 100 times this, I'm going to end up with 1.16. Round it off to the nearest whole number, it's 1. So 1. The website will receive. Now, this was equals, so it's exactly. And how many hits? 4 was our answer. So this is how you would answer the second part of this question. This is different than part 5, question 5. So we check answer. Fantastic. Now we go on less than 4. So I go back in to my StatCrunch, and you notice it opened up, it was there. So I want less than 4. So it's 0.0057. Okay, so let me close this down. Check answer. Okay, now the second part here, you're going to take 100 times this. If I take 100 times the probability, I'm going to get 0.57. That rounds off to 1 again because of the 5. And then this would be less than. So less than is what? Well, if we look up here in the problem, it says fewer than 4. So we're going to choose fewer than 4. So that comes right up from part B, fewer than 4. Check answer. We're good. Now, we want greater than or equal. So I open StatCrunch back up. And I wanted greater than or equal to. So it's 0.9943. Zero 0.9943. So we're good. And now if I take 100 times this, I'm going to get 99.43. So this is going to be 99 when I round it off to the nearest whole number. And what was the question? At least 4. So it's going to be at least 4. Check your answer. Okay? And that's how another type of question that you could run into. So here's a couple questions to help you understand how to use Poisson probability and StatCrunch. And this brings us to the end of section 6.3.